Okay, guys, let's get started. So today we're going to go over one of the exams from previous years. So this is midterm 1. It's going to be on chapters 4 to 8. Right? Everybody's clear on that? I would explain every problem here. If you have any questions, raise your hand and let me know. All right, so the first 10 questions are going to be based on this graph. So you would have, in this graph, you have the supply and the demand curve. You have the intersection point, which would be the equilibrium point. That corresponds to a certain equilibrium price and equilibrium quantity. And then as we go, we'll be asked different questions about this graph. So the first one is, what is the lowest willingness to pay of consumers who purchase this product in equilibrium? So what is the willingness to pay? What do we call willingness to pay? What does the demand curve represent? The willingness to pay of every consumer at a certain price, right? At a certain quantity, actually. So they have different willingnesses to pay, and at equilibrium, who's going to purchase the product? Well, everybody who's willing to pay at least the equilibrium price, right? So at equilibrium, the equilibrium price would be, what do we have here? 11, right? So the equilibrium price would be 11. Which means that everybody who's willing to pay at least $11 is going to buy this product. So what is the lowest willingness to pay of consumers who buy this product? 11, right? This is another way to ask what is the equilibrium price. And let me ask you this. What is the highest willingness to pay? 16, right? So that would be on the upper corner, or the intercept of the demand curve. Right, so the lowest willingness to pay, which is also the equilibrium price, in this case, that will be 11. All right, and what quantity do we have? What equilibrium quantity are we going to have in this market? 10, right? So equilibrium price is 11, and this is at a quantity of 10. All right, so answer B. The next question. If a price ceiling of $9 is imposed on this good, what is the consequence? So whenever we have a price ceiling or a price floor, the first question we need to ask ourselves is it binding or not binding, right? And to answer that question, we're first going to look at the original equilibrium, right, without any restrictions. And then we will see, after the price floor or ceiling, is this original equilibrium still legal? Right? If it's still legal to sell at that price, then it's not binding. Right? So the price or ceiling is not going to change anything. We're still going to be at the original equilibrium. However, if it's no longer legal to do what you wanted to do originally, then the price or ceiling is going to be binding, and there's going to be a certain consequence, either a shortage or a surplus. All right. Now, in this case, we have a ceiling of $9. Right? So we're here. There's a ceiling of $9. What does it say? That in this market, you cannot sell this good for more than $9. Right? That's what the ceiling does. It puts an upper limit on the price. So you cannot sell for more than $9. Are you trying to sell for more than $9? Yes, right? Because the original equilibrium was at a price of 11. So the original equilibrium can no longer exist. It's no longer legal to sell at 11. Therefore, this ceiling is binding, right? And what does it result in? Shortage, right? Because at 9, the quantity demanded, right? So where the price intersects the demand curve, the quantity demanded would be 14,000, right? But suppliers are only willing to supply 8,000. So there's a shortage, right? There's more people wanting to buy the good than willing to sell it. And there's a shortage of basically the difference, which is 6,000. Right, so this is the shortage amount. And it is a 14 minus 8, or 6,000 units. So the answer here would be A. Right? Okay. All right, the third question. If a tax of $6 is imposed on this good, what is the deadweight loss? All right, so now here we're going to have a tax. Is going to apply. We know it's of the amount of $6, right? So whatever buyers pay and whatever producers receive, right? The difference between those two would be $6. because the rest is going to go to the government. And it doesn't really matter whether it comes from the buyer's pocket or from the producer's pocket. That's always going to be the case. The difference between the price that buyers pay and the price that that producers receive is going to be the amount of the tax, right? So we need to find where is the difference between the demand and the supply curve? 6 units, because that's the amount of the tax. It is always going to be to the left of the original equilibrium, because we know when there's a tax, the market shrinks, right? So we need to find at which point is the difference between the demand and the supply curve 6, right? And we can look at, just count where the difference is 6, and I think it's here, right? So 1, 2, 3, 4, 5, 6, right? So this is where the tax is going to fall. And now in this new market, when there's a tax, now there's a decrease in the quantity being sold, right? The market shrinks, which is one of the consequences of taxation. Instead of selling 10,000 units of the good, now we're only going to sell 6,000, right? All right, so we know this distance here is 6, because that's the amount of the tax. And then we're after the deadweight loss. Right? The deadweight loss is the decrease in total surplus due to the tax. We know that total surplus, without any taxation, without any restrictions, would be the area of this big triangle, right? It would be the sum of consumer surplus and producer surplus. So total surplus would be this whole area. Now, after the tax, this part is no longer belongs to total surplus. This is effectively the loss that we suffer in total surplus because of the tax. And that's what we call deadweight loss. So the area of this triangle would be the deadweight loss. Now, if you look at it, then we can figure out what's the formula for deadweight loss, right? Theoretically, it would be, well, this is a triangle. The base is the amount of the tax, right? So the base would be the tax amount. And then the height would be this value here is the difference between the original equilibrium, right, the original quantity, and the quantity after the tax is implemented. Right, so it would be the quantity in equilibrium minus the quantity after tax, the whole thing divided by 2. Yep, this will be the deadweight loss for us. And now we know everything here actually, we can just plug it in. So the tax is $6. And then the difference is we started at 10, and now we're at 6, so the difference is 4 units. Divided by 2, it is 12, and this is in thousands, so $12,000. This would be the deadweight loss. Okay? So the answer would be C. All right, the next question. What is producer surplus in equilibrium? Right, producer surplus in equilibrium. So now there's no restrictions. We're back to the original scenario where we had equilibrium quantity of 10 and equilibrium price of 11. And we know producer surplus. So the supply curve basically represents the cost of producers, right? The cost to producing this good. And even though producers here have a very low cost, they still sell at the equilibrium price, right? So they get something out of it. And what they get out of it is what we call the surplus. Just as we had the willingness to pay for buyers, here we have the cost of producers, and the producer surplus would be the area above the supply curve, but below the price. Right? So the area of this triangle would be producer surplus, and then the area below the demand curve, but above the price, would be consumer surplus. And we said the sum of the two would be total surplus. So this here would be consumer surplus. Now we are after producer surplus. And again, we can express it with an equation. So producer surplus, if you look at the figure, we need to find the area of this triangle. It's a right triangle. So this side would be, actually, what is this point here?
The y-intercept.
The intercept of the supply curve, right? So I can name it, let's name it BS, the intercept of the supply curve. And in our case, it's 1, right? We can see it from the graph. And this here would be the intercept of the demand curve, right? This is when the demand curve when quantity is 0. And so that will be the intercept of the demand curve. And in our case, it's 16. I just want to label it so we can see what's going on. Right, so to find the area of this triangle, to find producer surplus, the length of this side is just the difference between the price in equilibrium and the intercept of the supply curve. Right? So it would be the equilibrium price minus the intercept of the supply curve times, and this side of the right triangle is just the quantity in equilibrium, right? Equilibrium quantity. So times the equilibrium quantity divided by 2. And that's all there is to it. Now I just substitute. I know equilibrium price is 11. The intercept of the supply curve is 1. The quantity I know is 10. Okay. Divided by 2. So it's what? 50. And it's in thousands because the quantity is in thousands. So producer surplus would be 50,000, or D. Do you have any questions so far? All right. Next question. Use the midpoint method to calculate the price elasticity of supply between the prices of 11 and 13. All right. All right, so I know the midpoint method for elasticity. This will be the elasticity of supply, so keep that in mind. We'll be tracking the supply curve, not the demand curve. So the elasticity of supply with the midpoint method would be the difference in quantity divided by the average quantity, and the whole thing divided by the difference in prices divided by the average price. Right? Now I need to find the elasticity of supply between the prices of 11 and 13. So if the price, I'll name it P1, is 11, what would be the quantity supplied? At a price of 11, the quantity supplied is 10. We know that's the equilibrium point. And if the price is instead $13, the quantity supplied would be, so this is 13, right? The quantity supplied would be all the way here, and it would be 12, right? Now I know all the Q's and all the P's. I just plug it in the formula and calculate. So the elasticity of supply would be the difference between the Q's is 2. Now here we're going to have a positive number for sure because we know the supply curve is upward sloping. But when we calculate the elasticity of demand, it would always be negative, right? Because the demand is downward sloping. We still report the elasticity as positive though, right? So just with the elasticity of demand, ignore the negative sign. When we talk about income elasticity or cross price elasticity, then we do not ignore the sign because the sign is pretty much all that matters, right? So the elasticity of supply in this case would be the difference between the Q's, which is 2, divided by average Q, which is 11, right? And the whole thing divided by the difference in P's, which is 2, divided by the average, which is 12. Right? So I can put this as 2 over 11 divided by 2 over 12. When you divide by a fraction, you multiply by the reciprocal, so it's 2 over 11 times 12 over 2. The 2 cancels. And then we have 12 over 11, which is about 1.09. Right? And then our answer would be D. Now, does that mean that the supply curve is elastic, inelastic, or unit elastic between those 2 points? Elastic, right? So 1 was the cutoff point. 1 is unit elastic. When it's more than 1, we have elastic supply or demand, and when it's less than 1, we have inelastic. Right? question is, how did I get the average? Well, the average between 11 and 13 is 12, right? You add them, divide by 2. And the average of Q1 and Q2 would be 11 because you add them and divide by 2. All right, any other questions? Yes? How did I get that Q2 is 12? I'm given the two prices, right? And I'm looking for the elasticity of the supply curve. Right? So I would take the first price and see what quantity, based on the supply curve, it corresponds to, and it's 10. Then I would take the second price, which is 13, and again, see what quantity supplied it corresponds to. And it turned out to be 12. Okay? All right, moving on. So the answer here is D. Which of the following is the equation for the demand curve? Right, so the demand curve is a straight line here, and we know the equation of a line is always going to look like y equals b plus mx, where b is the intercept and m is the slope. Now, in our case, y would be the price, right? And the x would be the quantity. Right, so I have b plus m quantity demanded. I'm looking for the equation for the demand curve. So first thing we can easily see is what is the intercept of that curve? 16, right? We already know that. So this is 16. And that eliminates none of the answers, because all of them have an intercept of 16. However, what else do we know about the demand curve? It's downward sloping, right? So the slope would be negative, right? So therefore, those two get eliminated right away. And it's either A or B. So what we need to figure out now is whether the slope of the demand curve is -2 or -1/2. Right? And for this, you can choose any 2 points on the demand curve. And then the slope would be the rise over the run. Right? You can choose the intercept and the equilibrium, or any 2 points that are nicely defined so that you can see what's going on. For example, if I move from here to there, seems like this would work. Right? From the intercept to this point, what is the rise? 1. What is the run?
2.
So the slope is?
1/2.
-1/2. Right? So this is -0.5 QD. And there we have it, the equation of the demand curve. Right? That will be answer B. And as an exercise, what will be the equation of the supply curve? What's the intercept?
1.
What's the intercept of the supply curve? 1. Plus for sure, right? And then let's look at this and that, those 2 points. What's the rise? 2. What's the run? So 2 over 2, 1. There you go. Okay? All right, our answer is B here. All right. Using the point slope formula, what is the price elasticity of demand if 12,000 units of the good are sold? Okay. Now we know the point slope formula, and we're looking for that for demand elasticity. So the point slope formula for demand would be 1 over the absolute value of the slope and of the demand curve in this case, times P over Q. And P and Q are just that, the P and Q at that point that we're looking for the elasticity at. We're told that what is the price elasticity of demand if 12,000 units of the good are sold. So at 12,000 units, which is here, right, quantity is 12,000. We need to figure out what price corresponds to that for the demand curve, though. and this would be 10. Okay, so we know that at that point, price is 10 and quantity is 12. So the point slope would be, the point slope elasticity would be 1 over, what was the slope of the demand curve? We just calculated it for the previous problem. A half, right? Negative 0.5, but it's an absolute value, so it's a half, yeah, over 0.5. And then times price over quantity, so 10 over 12, right? This is, if I flip this fraction, it becomes 2 times 10 over 12, or 10 over 6, or 5 over 3. Right, do you see this? So it's here. Answer D. All right, question 8. What is the proportion of tax incidence on sellers for a tax of less than $15 per unit? All right. So since both the supply and the demand curve are linear, the tax incidence on both sellers and buyers is going to be constant, right? It's not going to change. So the proportion of the tax that sellers pay and that buyers pay is going to be the same for any amount of tax. And the up to $15 of tax, $15 of tax would basically deplete this market, right? Because the tax would be the difference between the demand and the supply curve, and the difference here is 15. So if you tax more than 15, there's no market anymore. Nobody's going to buy and sell that good. So that's what the 15 represents. But for anything less than 15, the proportion of tax that each of the buyers and the suppliers pay is constant. It does not depend on who actually ends up, paying the tax, whether it's all imposed on buyers or all imposed on sellers. They're always going to share the burden with a certain proportion. And to find that, an easy way to do this would be, so for buyers, this is the equilibrium, right, at 11. For buyers, they're going to pay the ratio of this distance to this distance. And sellers are going to pay 1 minus that, right, the rest of it. So they're going to pay the ratio of this distance to that distance, to the full again. So I can calculate it for both of them. I'm asked for the tax incidence on sellers. Again, as a formula, it would be, so this distance here is the difference between the price in equilibrium and the intercept of the supply curve. Right, so it will be the price in equilibrium minus the intercept of the supply curve, and then divided by basically the difference in the two intercepts. Right? The intercept of the demand curve minus the intercept of the supply curve. Right? And if I were to calculate this for buyers, it will be the difference between the demand intercept and the equilibrium price, again divided by the difference of the two intercepts. Right? So now I just plug in. I know what's the price in equilibrium is 11. The supply intercept is 1. And then the demand intercept is 16 minus 1. So it's 10 over 15, or 2 over 3. So for sellers, they're always going to bear the burden, the 2/3 of the tax burden. And sellers are always going to bear 1/3 of the tax burden. Okay? Which one is that? That will be C. Another way to look at this is we had the tax of $6 at some point, right? It was right here. Right? So even if they share it, or only the buyers pay, only the sellers pay, they're still going to end up with, so the total tax is $6. The price that buyers pay in this scenario is what? Here it's 13, right? And the price that sellers receive is 7. Right? That's the scenario where we had the $6 tax. So what happened here is that before the tax, buyers paid 11. Now they pay 13. So they are suffering a $2 loss. And sellers used to get 11. Now they only get 7. So they suffer a $4 loss because of the tax. Right? So buyers suffered 2 out of the $6, or 1/3. And sellers end up paying 4 out of 6, or 2/3 of it. Right? And it's going to be true for any amount of tax. Do you have any questions? All right, so answer C for this one. Okay. Okay, suppose this figure represents the rental market for apartments in Jersey City. The dollars are given in hundreds, right? So all of those would be in hundreds. We still have the equilibrium, right, which was at 1100. What is the minimum surplus available to lessees, which is the buyers in this case, right? Because this is apartments. If there is rent control on efficiencies of 800 per month. So we have rent control. What does rent control represent in general? A price ceiling, right? It says that you cannot sell or rent these apartments for more than that amount. So we have a ceiling of 800 per month. 800 is here. So first of all, we need to figure out, is that a binding or a not binding ceiling? It's binding, right? Because it says you cannot sell for more than 800. Do you want to? Yes, because you want to sell at 1100, right? You can no longer sell at the initial equilibrium, so we have a binding ceiling, and that results in what? Shortage, right? Because this is the amount of the number of apartments that sellers are willing to lease, and this is the amount that buyers demand. So we're at 16 here, and they only want to rent 7. So 7,000 and 16,000 actually. All right? So now, in this question, we have what is the minimum surplus available to the buyers? The minimum surplus available. What's going on here is that let's say 16,000 people want to rent an apartment, right? Only 7,000 of them will end up renting. Because let's say that's all the available units at that price. Now, out of those 16,000, do we know exactly which 7,000 would rent the apartment? Sorry? We don't know that, right? And the buyers differ based on their willingness to pay. Right? So this buyer here might rent, and then that buyer there. Correct? So they would have different willingness to pay. And the difference between their willingness to pay and the price is the surplus. True, right? The area below the demand curve above the price. That gives you the buyer's surplus. So to minimize that, right, the question is what is the minimum surplus available to them? So who needs to rent those 7,000 apartments so that the surplus is minimized?
The ones with the lowest willingness to pay.
Exactly, the guys with the lowest willingness to pay. And we have, so the guys with the lowest willingness to pay are here in that part of the demand curve, right? And we want 7,000 of them to rent because that's how many apartments we have available. So starting from 16 back, only 7,000 apartments would be rented. So from 16 to 9 here. Those guys are going to end up renting the apartments, right? And what is their surplus? Well, the surplus is, as usual, the area below the demand curve, but above the price. So the minimum surplus available to lessees in this market would be the area of this triangle.
Why is it 9?
Because 7,000 apartments are available, right? If we start giving them to those people here, right, with the lowest, there's only 7,000 of them that are going to get rented, that are going to get an apartment. So 16 minus 7, so it goes from 16 to 9. All right. So just find the area of that triangle. And what would happen if we were looking for the maximum surplus available?
So we go from like the highest willingness to pay. So we would go from like the
From 0 to 7, right? So if we were to rent if we were to maximize the surplus, we would rent the apartments to those guys here in the beginning. All right. So first of all, here we know what that is. This is a right triangle. We need to find its area. We know what that is. That's 7, right? Because that's how many apartments get rented. And then this here we can figure out. We can actually see in the graph what it is. So this is 11.5 here, like the intercept. So 1,150. So this is 3,050. No, sorry, this is 11.5. Yeah, 350 is the difference, and this is 7,000. Multiply, divide by 2, and we get our surplus. Okay. 7,000. So 350 times, I'm doing something wrong. That should be the answer, right? This is 7,000 divided by 2, 3,500 times 350. We should have this. That will be answer A. Okay. The other way to find what that point is, if we're not given the graph, would be to figure out what is the demand at a quantity of 9. Right? So if we have the demand equation instead of the graph, we can just plug in the quantity of 9 and figure out what the price is at that quantity. Okay. All right. Any questions? All right, so this is the last question that refers to the graph. All right, suppose the price of an important raw material to make this good decreases. All right, so what happens here? The cost of producing this good goes down, right? And also the number of buyers increases. Which of the following combinations of equilibrium price and quantity are possible? Right? So what's going to happen when the cost of producing this good decreases? Supply increases. Right? It's cheaper to produce the good now, so we're going to produce more of it. An increase in supply would be a shift to the right. Okay, so just draw it anywhere. And the other condition was that the number of buyers increases. What does that cause? Demand goes up, right? There's more people willing to buy the good. Demand goes up, and that's a shift to the right of the demand curve. All right, so here's where I ended up, the way I drew it. What we know for sure is that since both the demand and the supply curve increase, the quantity in equilibrium is going to go up for sure. Right? So we know that the quantity is going to be higher than the original quantity of 10. However, we're not the result or the effect on the price is going to be ambiguous. Right? Because the way I drew it, it is higher than the original price. But if the demand curve was shifted by just a little bit instead of that much, they would intersect somewhere here, and the price would be lower. Right? So the effect on price is ambiguous. Quantity for sure goes up. The original quantity was 10. So I can eliminate just the first answer, right? This is not possible for sure because the quantity should be more than 10. What else I know though is that if you imagine that the supply and the demand curve separate this graph in 4 regions, right? This region, that region, and that region. There's no way for the new equilibrium to be in this region, right? Because for it to end up here, then both the demand and the supply curve would need to decrease, and we know that they both increase. For it to end up here, right, the supply curve needs to go down, and it goes up. So that doesn't work either. And to end up here, the demand would need to decrease, and we know that it increases. So there's no way for the point to be in either of those 3 regions. The only possibility is that it ends up in that region here. All right? And now that we know that, we can just figure out where those points lie, and there's only going to be one of them that lies within that region. All right? Does that make sense? Okay, so what we have here is 9, 11 at a price of 9, and quantity of 11 is here. That's outside of the region, right? So that doesn't work. 15 and 12 at the price of 15 and quantity of 12. Whereas this is 12, it's right here. Okay, so that doesn't work either. And then there's only one, 14, 14. At a price of 14 and quantity of 14, which is here, then we are in that region. So that's the only possible equilibrium. Okay, any questions? Right, so this is answer D. Okay, so now instead of having the graph, we have the equation of the demand curve and the equation of the supply curve given. And we're going to answer a series of questions about that scenario. And I want to point out that having the equations and having the graph is exactly the same in terms of the information that it gives you. Right? So based on these equations, I can draw the graph perfectly and know everything about there is to know about this market. Right, and we'll see how that works. Okay, so first question is, so there's a demand curve represented by that equation and the supply curve represented by the supply curve equation. Prices in dollars, quantities in thousands. What is the equilibrium price in this market? Right? So what is the equilibrium price? How can I find the equilibrium price?
You're going to set the 2 equations equal to one another.
I'm going to set the 2 equations equal to one another because I know that in equilibrium they're going to intersect. At that point of intersection, the quantity is going to be the same and the price is going to be the same for the 2 curves. Right? That's the point of the intersection. So the price in equilibrium of the demand curve is going to be equal to the price of the supply curve in equilibrium. Okay, so I can just plug in the 2 equations here, set them equal to each other. And instead of using QD and QX, I'm going to use Q star because QD is going to be equal to QX at equilibrium. Right? So just get 90 minus 2Q, and I'll name this Q star, is going to be equal to 10 plus 3Q star. So now I just, one equation, one unknown. I'm solving for Q star. What is it? 80 equals 5Q star, or Q star equals 16. Okay, so I know the equilibrium quantity is 16,000 units. However, I'm asked about the equilibrium price. So what do I do now? Right? So this 16 corresponds to the equilibrium price in both the demand and the supply curve, because the prices are the same there. So I can plug this quantity in any of the 2 equations, and that's going to give me the equilibrium price. So if I do the supply curve, for example, then I'm going to have 10 plus 3 times 16, which is 48, $58. Right? So for this this question, the answer is 58. And as we go to the other questions, it would help to have the graph right? So we can mark the information that we already know on this graph. And I'll draw it next. All right, so in this case, answer A. Okay. We'll put the graph here. This is the demand curve. This is the supply curve. I know the equilibrium price was 58. And the equilibrium quantity is 16. What else do I know about these two curves? What else can I label?
Well, you could label the y-intercepts of both supply and demand.
Exactly. I can label the two intercepts, right? What is the intercept of the demand curve? 90, right? I know this from the equation. So the intercept here would be 90. What is the intercept of the supply? 10. Okay, so I have the graph. And then I can answer the rest of the questions. What is total surplus in equilibrium? Okay, same scenario. I'm after total surplus. And total surplus would be the area of this big triangle here, right? It's the sum of producer and consumer surplus. And the area would be the base, right, times the equilibrium quantity divided by 2. So the base is the difference between the two, right? The difference between the two intercepts, the intercept of the demand and the intercept of the supply, times the quantity in equilibrium divided by 2. Right, so I can just plug this in now. I have 90 minus 10 times 16 divided by 2. What is this? 640,000. Correct? Right, this is 80 times 8, yeah. And the quantity is in thousands, so that's why we get this. Any questions? Yep.
Do you mean the top region or the whole shade?
The question is, which region do I mean? The total surplus is this whole region. The top region only, below demand, above price, is called what? Consumer surplus. And the other one, above supply, below price? Producer. And total is the sum of the two. All right, so answer here is C. All right, the next question is, which curve is more inelastic in equilibrium? All right. So in equilibrium, let's look at, we're going to compare the elasticities. We're going to use the point slope formula for that. So at the equilibrium point, the point slope elasticity of demand would be 1 over the slope of the demand curve times, and this is P over Q, but this is in equilibrium, so it's P star over Q star. And then the point slope for the supply curve would be 1 over the absolute value of the slope of the supply curve times P in equilibrium over Q in equilibrium. So basically, this part is going to be the same for the two elasticities, right? So the relative elasticities would not matter in this case. So this part does not matter. The question is, which curve is more inelastic, right? So to be more inelastic, the elasticity needs to be lower, right? More inelastic. So the question is, which elasticity needs to is lower? Sorry, and the elasticity that is lower would have a higher slope. All right. So the question is, which is more inelastic? That is, which has lower elasticity, which has a higher slope. And then we can just compare the slopes. The slope of the demand curve is 2, and the slope of the supply curve is 3. So the more well, the more inelastic is the supply curve. Okay. So that will be A. Any questions? Right. Next question. What is the deadweight loss associated with a tax of $20 per unit? All right, so what we know about the deadweight loss? We know that for any tax, it's going to be true that the price buyers pay and the price suppliers receive. The difference between those two would be the amount of the tax. Okay, so this here would be 20. And then to find the deadweight loss, which is this region, we will take the amount of the tax and multiply it by, now the height in this triangle would be the difference between the quantity in equilibrium and the quantity after the tax is imposed. Right? This will be the quantity after the tax. So the deadweight loss will be tax times quantity in equilibrium minus quantity after the tax, the whole thing divided by 2. All right, so I know what the tax is. I'm told it's $20. The quantity in equilibrium was 16. Right, I found that in the first question, but I do not know what is the quantity after the tax. So as soon as I find that, I could solve for the deadweight loss. How can I find the quantity after the tax? This quantity here. I'm going to use the equations, right? And what I know is that the demand minus the supply, the price of the demand minus the price of the supply is going to be equal to 20. And the quantity at that point is going to be the same for the supply and the demand curves. Right? So the difference between the two should be 20. And quantity S and quantity D, I can just set equal to quantity after tax because it's the same. Right? And so that's what we need to do here. All right, so I start plugging in. So we have 90 minus 2Q, and I'll make this Q after the tax. Right? And the whole thing minus, where's the supply? Over there. So minus 10 minus 3Q after the tax is going to be equal to 20. Correct? All right, so we just solve for quantity after tax. What is this? 60 equals 5 quantity after tax. So quantity after tax equals 12. So this is 12 here. And now knowing that, right, the loss in quantity turns out to be 4,000 units. I can just plug that in, and I'm going to find the deadweight loss. So it's going to be the $20 tax times 16 minus 12, the whole thing divided by 2, or 40,000. Right, so this is 4 times 10. 40, and then the quantity is in thousands, so 40,000. The answer would be C. Any questions so far? All right. Okay, so we have a tax of $6.8 per unit on this good. All right, so let me do this. There's a tax of 6.8 per unit on this good. The cost of each supplier increases by 4.65 per unit, and the tax remains in place. What happens to deadweight loss as a result of this change in cost? All right. It always helps to draw the graph when you have different scenarios and see what's going to happen. So we have a certain amount of tax. Doesn't really matter what it is, right? So it's right here. This is the $6.8 of tax, let's say. This is deadweight loss here. Right? It's the amount of the tax times the quantity lost, divided by 2. What happens now is the cost of each supplier increases. What does that do to the graph? What's going to happen? Right, so the cost increases, so the supply is going to decrease, right? And a decrease in supply is a shift of the supply curve to the left. So this is our new supply. And let's imagine it doesn't really matter where it is, over here. It's a parallel shift of the supply curve. Right? So what is the new? Well, the tax is exactly the same. So the difference in demand and supply would be exactly the same. The question is, would the deadweight loss change, decrease, increase, right? What do you think is going to happen? It's going to stay the same, right? Because, well, the tax is going to be the same in any case, so the only thing that it depends on is the loss in quantity, right? Here we lost a certain amount of quantity from the original scenario, and here we're going to lose some quantity again. The question is, are we going to lose more or less, right? Is the market going to shrink more or less than before? The answer is that it's going to be exactly the same, because the deadweight loss depends on the relative elasticities, the relative slopes of the demand and supply curve, not on the, right.
So it just takes up like a different price and the graphs essentially stay the same basically. I mean, I have different price, but like just different location in the supply curve, and it just takes in the same tax wedge.
So the question is whether we just take a different location of the supply curve and the tax stays the same. That's exactly right. So the only thing that's going to change is there's a shift in supply, right? But the tax, it says the tax remains in place. So the tax amount is exactly the same.
But is there a new equilibrium?
There's going to be a new equilibrium,
Okay.
right? But the question is about the deadweight loss,
Okay.
right? The deadweight loss is going to stay the same because it depends on the relative elasticities of the two curves, and because we had a parallel shift, neither the slope of the demand curve nor the slope of the supply curve changed, right? So the deadweight loss is going to stay the same. And that will be answer C. And you had a question.
Yeah, if the tax would have changed, then if it would have increased, then it would have shifted, like, how would it shift the demand, how would it shift the deadweight loss if the tax was increase or decrease?
The question is, if the tax would increase or decrease, how would the deadweight loss change?
Yeah, would it, like, if the tax will increase, will the deadweight get smaller, or will it, like, will it have more of an increase?
If the tax would increase, the deadweight loss would always be higher, right? Because it's just basically moving for the higher tax, the higher the tax, the further to the left we move. And as we move to the left of the original equilibrium, the deadweight loss is increasing. Okay. Any other questions? All right. So in our case, the answer was C. The deadweight loss is going to stay the same because the slope of neither the demand or the supply curve changed. Okay, now suppose the supply curve becomes more elastic, but equilibrium is unchanged. What happens to the tax incidence on sellers? So again, this would be a general rule, so it helps to have a picture. And then we'll see. So originally, we just draw it. Doesn't really matter what we do. So this is the supply, this is the demand. This is the original case. We're asked about what happens to the tax incidence on sellers, right? And we said that tax incidence on sellers, this is the proportion of the tax that sellers are going to pay, is always going to be the ratio of this distance to that distance. So the question is, as the supply curve becomes more elastic but the equilibrium stays the same, is this ratio going to be higher, lower, or the same? And let's just draw it and see what happens. So the supply curve is going to become more elastic, which means it's going to become flatter or steeper? Flatter. Like the more flat it is, the more elastic the curve. So the equilibrium is going to stay the same, right? So it still needs to pass through that point, but it's now going to be flatter. Okay, so this is the new supply. Now after the change, let's see what happens to the tax incidence on suppliers. Now it's this divided by that, right? So that's the ratio that we're looking at. Is it smaller or larger or the same? Smaller, right? So they're going to pay less of the tax now. They're going to be responsible for less of the burden of the tax. So the tax incidence on sellers is going to decrease. Okay, that's A. All right. Okay, suppose a tax of 1.5 per unit is placed on buyers. Okay, so buyers pay the tax. Buyers pay 1.5 and sellers pay $3. What is the proportion of tax incidence on buyers? Any ideas? Okay, so they pay 1.5 of the tax, and sellers pay $3 of the tax. Tax incidence on buyers is what we're after. So the first suggestion is that it will be 1.5 over 4.5. However, what did we say? Does it matter who pays the tax? Right? Even if the whole tax was imposed on sellers, let's say. Right? So if sellers paid $4.5 of tax, buyers paid nothing. Does that mean that buyers pay or bear none of the burden of taxation? No. Right? So how they split the cost actually, whose pocket it comes out of, doesn't really matter. We know that the tax incidence is going to be the same.
So does it then depend on the elasticity of the demand and supply?
It would depend on the elasticity of the demand and the supply. Here we asked what it is. Right? We calculated that already. We know it's the ratio of this distance to that distance. And we can just take this. We know all the values here. We've calculated them before. So the tax incidence on buyers is going to be the difference between the intercept of the demand curve and the equilibrium price divided by the difference between the two intercepts. Right? So it's basically that divided by this whole thing. Agreed? Now, that's why when we have the graph, we can easily see what the numbers are. We've already figured them out. So it's 90 minus 58 divided by 90 minus 10. Right? And this ratio would be, so what is it? 32 divided by 80 by, what is it? 10, 2 over 5. Right?
Can you move them? Sorry.
So 2/5 is what they're going to pay, what buyers are going to pay. Is that right? 17? Yeah. 2/5 of any tax is what buyers are going to end up effectively paying. Right? It doesn't matter how much money comes out of their pocket, who pays the government. That's the burden that they're going to bear out of any tax.
I have a question, actually.
Yep.
So if the question was reversed and it said, what is the incident on the sellers instead of the buyers, would it then be the intercept of supply minus price over BD minus BS instead of BD minus price?
The question is, what if the, I need to repeat the question, because,
Okay.
The question is, what would happen, what would change in this formula if we were asked about the tax incidence on sellers instead of buyers? And now we know that it's going to be, we already solved this before, right? It's this divided by that. So the denominator is going to be the same, right? The denominator is always going to be the difference between the two intercepts, and the numerator would be the difference between the price and equilibrium and the supply intercept. Right? It's not, well, this is going to be, but also it needs to change the sign, because right now the equilibrium price is higher than that. And if you calculate the tax incidence on buyers, which we just did, it's 2/5. What is the tax incidence on sellers then? 3/5, right? The rest of it. Okay? Alrighty. Where's my? So answer C here. All right. Suppose the cost of each supplier increases by 1 cent per unit. What happens to total revenue in equilibrium in this market? All right. So again, if we draw the picture, supply, demand, what changes, right? So what happened here? The cost of each supplier increases by 1 cent per unit. So the cost increases. Supply decreases, right? So because it's more expensive now to produce the good, we're going to produce less of it. That means a decrease in supply, which is a shift to the left. So supply is going to decrease. What we have is a new equilibrium, right? This was the original equilibrium. This would be the new equilibrium. In that new equilibrium, the price is higher, right? But the quantity is lower, right? You see that. So total revenue before the shift, well, total revenue in general is for suppliers, it's price times quantity, right? Total revenue is price times quantity. Now what's going to happen, we said, is that the price is going to go up after the change, right? After the increase in costs. And the quantity is going to go down. So we're not really sure what's going to happen to total revenue, right? Because one variable goes up, but the other goes down. So we need to figure out which one dominates, right? Which effect dominates. And let's see what the possibilities are. So basically, if the percentage change in price is lower than the percentage change in quantity, okay? So percentage change in quantity is higher than percentage change in price. What happens to total revenue? So this is higher than that. The negative effect dominates the positive effect. So total revenue decreases. Total revenue is going to go down. And what kind of situation do we have here when a change in quantity is higher than change in price? It's elastic, right? Because the elasticity is percentage change in quantity divided by percentage change in price. So if this is higher than that, then we're going to have an elasticity of more than 1, right? Or elastic. And now this elastic curve refers to the demand curve, though, not the supply curve. Right? So if the demand curve is elastic and we change the price, or we increase the price, total revenue is going to go down. And the other scenario that we have is that the change in price is higher than the percentage change in quantity. So now the positive effect dominates the negative effect. Therefore, total revenue goes up. And this is the case when we have inelastic demand, right? Because now this would be, the numerator would be smaller than the denominator, so we have inelastic. So the question comes down to whether the demand curve is elastic or inelastic at that point. And if it's elastic, then total revenue is going to go down. If it's inelastic, total revenue is going to go up. And that's all there is to it. So I need to find the elasticity of demand at equilibrium so that I see what happens when we change the price. Okay? And we use the point elasticity in this case. It's 1 over, and this is for the demand curve, it's 1 over the slope of the demand curve, absolute value, times the P over Q. And this is an equilibrium, right? I start at the equilibrium point, so I want to see what happens at that point. We know the slope of, what was the slope of the demand curve? -2, right? It's right there. So it's 1 over 2 times, and P was 58 divided by 16. So it's basically 58 over 32. So it's more than 1 for sure, right? That means that the demand curve at that point is elastic, right? Therefore, if we increase the price, which the supply shift is going to do, right? If we increase the price, the change in quantity is going to be higher, right? The decrease in quantity is going to be higher than the increase in price. Therefore, total revenue is going to go down. All right? That's C. Any questions? All right. Okay, and we're done with that scenario. Okay, suppose the government has adopted a tax at the peak of the Laffer curve. which of the following statements is false? So what is the Lafayette curve? It represents the relationship between tax, the amount of the tax, and the tax revenue that the government gets. And the Lafayette curve is always has a shape like that. Right? So at some point, when tax is zero, there's zero revenue. As we start increasing the tax, right, as the government imposes a higher and higher tax, total revenue of the government is going to increase until it reaches a certain point, which is the top of the Lafayette curve. Right? At that point, let's say tax star, at that point, the government is going to get as much revenue as it can. After that point, if it starts increasing the tax, the tax revenue is actually going to decrease. All right, so let's see the statements that we have. We are already, so the question says that we have adopted a tax here. So we are at the peak. Is it true that an increase in the tax will increase tax revenue? So increase of the tax means, right, we move to the right. And we move to the right, what happens to tax revenue? It goes down. So A is false and the answer, because the answer is, the question is what is false. But let's just check the other ones again. A decrease in the tax will decrease tax revenue. Is that true? Yeah, because then we'll be moving that way. Tax revenue is maximized at the current tax. Is that true? Yes, right? Because we're at the top of the Lafayette curve. It cannot get higher than that. The slope of the Lafayette curve is zero at that current tax. Yeah, right? Because the slope at the maximum of a curve, right? It's the slope of the tangent line. The tangent line is horizontal there. Okay. So the question, the answer is A. Okay. What is the income elasticity of demand if a 10% increase in income results in a decrease from 22,000 to 18,000 units sold per week? So income elasticity, the formula for that is the percentage change in quantity over the percentage change in what? In income, right? That's because that's income elasticity. It could be, right, so here the sign is going to be very important, and the cutoff point would be 0, right? The cutoff point for elasticity was 1 when we had elastic and inelastic. For income elasticity, the cutoff point is 0, and when income elasticity is greater than 0, is positive, what do we have? What does it tell us whether income elasticity is positive or negative? Not in this case. Generally, what? Sorry? Normal good or inferior good, right? So if the income elasticity is positive, that means that as income goes up, the quantity demanded goes up, which is a normal good. And if it's negative, that means as we get more money, we buy less of that good, right? And that's inferior good, by definition. That's the definition of an inferior good. Okay? Right, in this case, we're asked to calculate it. So what we know is that there's a 10% increase in income, right? So our denominator would be 10. And there's a decrease in quantity from 22 to 18. So I need to find the percentage change in quantity. And again, using the midpoint formula, that will be Q2 minus Q1 divided by Q1 plus Q2 over 2, right? The difference, the change in quantity divided by the average quantity. And the change in quantity, well, it decreased. Again, here we need to be careful about the sign. It decreased from 22 to 18. So Q2 is 18 minus 22, right? Divided by the average of those two, which is 20. And I can ignore the thousands because they're going to cancel. What is that? Minus 4 over 20 or minus 20%. Right? It's minus 1 over 5, which is 0.2 or minus 20%. So now my income elasticity would be minus 20 divided by plus 10, right? Because your income increased. It's minus 2. And that's A. And what kind of good do we have? Inferior good. All right. Okay. Suppose the equilibrium price of a good is 50. If sellers are taxed $5 per unit and the new equilibrium price of the good is 52, what is the tax incidence on sellers? Right? So what happened here? There's a tax. What is the amount of the tax? So the total tax is $5. Who pays it? Does it matter? No. All right, so the total tax is $5. What happened is the original equilibrium, the price before tax was $50, right? And it was at efficient equilibrium, so buyers paid 50, sellers received 50, true? Now after the tax, the new equilibrium price, so the price after the tax, would be $52. So what do buyers pay? Right, buyers pay $52 now for the good instead of the 50 that they used to pay. So the burden on buyers is going to be the new price that they pay minus the original price that they paid, or $2. So the burden on sellers, 3. And actually what happened here is that because, all right, so originally buyers paid 50, sellers received 50. Now buyers pay 52 after the tax. But what do sellers get? 47, right? The buyers pay 52, but sellers get the 52 and they need to give away 5 to the government. Right? They need to pay the tax too. So they get 47 only. The question is, aren't they just paying $3 in taxes? That's how much of the burden they get. What comes out of their pocket is the $5.
This is always completely ignored when it says buyers and sellers are taxed, because it doesn't matter, basically, right?
Always complete. The question is, should we always completely ignore who pays the tax? Pretty much, yeah. Yeah, it's gonna matter as to what is gonna matter? As to what the new price is gonna be, I guess. No, even there it doesn't matter really that much.
Even if they say the sellers pay 100%, it's actually still ignored.
Even if they say that the sellers pay 100% of the tax, which is what we have in this case, that doesn't mean that they get 100% of the burden. They do end up paying it, right? It comes out of their pocket. They pay the $5 tax to the government. However, buyers give them 52 only, right? So if they give them 52 and they pay 5 to the government, then 47 is what they end up receiving after the whole thing is said and done. And they used to get 50. So actually they only suffer a $3 loss, not the $5 that they end up paying, because buyers get some of it through the higher price that they pay. Okay? So the burden on buyers would be the $2, and the burden on sellers would be, now they used to get 50, now they only get 47, right? So they paid $3. And that's all there is to it. I mean, you can find either of those, and the other party is going to end up bearing the rest. So the tax incidence on sellers is 3/5, right? The tax incidence on buyers is 2/5. And it's going to be that way no matter what tax we impose on them. Right? They're always going to share the burden in that way because it depends on basically the relative elasticities of the supply and demand, and not on the amount of the tax or who pays it. Okay, any questions? So here, what was this? B? Yeah, the answer is B. All right, suppose the willingness to pay of 6 potential buyers are those, and the costs of 8 potential sellers are the following. Which of the following represents an equilibrium price for this market? All right, an equilibrium price for this market. So we have 6 buyers and 8 sellers. We know that the equilibrium is going to happen at this point, at some point. Before that, look what happens before that. The willingness to pay is higher than the seller's cost, right? Then as they meet at some point, and after that, then the supply curve is above the demand curve, so the seller's cost is going to be higher than the willingness to pay of buyers. So basically, we're looking at the point at which the willingness to pay is, well, it's actually, if the curves are continuous, they're going to be exactly equal, right? The willingness to pay and the cost of sellers. But because we only have a few points on this curve, so we're looking at the point at which the willingness to pay is the smallest. Sorry, the difference between the willingness to pay and the cost of supplier is the smallest, but still positive, right? So if we rank them, if we rank the buyers starting from the one with the highest willingness to pay, and the sellers starting with the one with the lowest cost, then we'll see when they're gonna intersect. All right, so this is buyers and this is sellers. What's the highest there? Where do we start? 26, 25. What is next? 20, 18, 16, and 12. Okay? So if 4 units or if 3 units are sold, let's say, right, at a price of 20, there's going to be 3 people willing to buy the goods, right? That guy and the 2 guys with higher willingness to pay. And then you go down and the willingness to pay goes down. So at 4 units, sorry, at 18, 4 units would be sold, and so on and so forth. Now, on the other hand, we need to see what suppliers are willing to sell. So here we start here at the lowest point. So the cost would be increasing. And what's the lowest? 8, 12. What else is there? 15, 14, 15, 18. There you go. All right, so this is at 7 or 8. Okay, so see what happens. So the difference between the willingness to pay and the cost is highest here. And then as we move, as more and more people buy this good, the difference becomes smaller and smaller. And you see at the equilibrium point, on the left of it, so at this quantity, willingness to pay is higher than seller's cost. And on the other side, right, after the equilibrium, it's vice versa. The willingness to pay is smaller than the supplier's cost. Right? So basically, somewhere between 4 and 5, this happens. Now, we don't have continuous, right? We can't buy 4.5 of the good. So what's going to happen is that the equilibrium price is going to be somewhere between 18 and 16. The only one, right, the only one that fits is B, 17. Question?
How do you measure willingness to pay on the graph?
How do you, sorry?
How do you measure willingness to pay on the graph?
How do you measure the willingness to pay on the graph? Well, the graph is the willingness to pay is the demand curve. Right? So if I were to plot those points, that would give me the demand curve. One guy wants to buy at 26. That's 1 point. Then second guy here is going to buy at 25. That's another point, and so on and so forth, and that will give me the demand curve. Right? Then if I plot the supply, it will be, those points would represent the supply curve. And at some point here, they're going to meet. And that happens somewhere between 18 and 16. And at the price of 17, there's going to be 4 people willing to buy the goods, right? Those first 4. And there's also going to be, at the price of 17, there's going to be 4 sellers, right? The ones who have a lower cost than that are willing to sell. Right? So answer here is B. All right. What is a likely consequence of a binding minimum wage? All right. What does the minimum wage state? It's a floor, right? You cannot pay less than that. And we told it's binding, right? So if there's a binding floor, that means that right here, that if this is the original equilibrium, and there's a binding floor, right? The original equilibrium no longer can exist, right? So you're forbidden to sell for less than the minimum wage, okay? So you're forbidden to hire people for less than that amount. And what do we get here? What is that called? A surplus. Now this is the labor market, all right? So a surplus of labor is unemployment, right? So there's more people willing to work than there's employers willing to hire them. So we get unemployment. That's the consequence of a minimum wage. Is it true that we're gonna get cash or under the table salaries?
Yep.
Yeah, right, because there's a lot of unemployment. People are gonna look for employers that, people are gonna be willing to work for less than the minimum wage, and that is not legal, so it needs to be under the table. Right, so that will be true. Is there a decreased total surplus? Yeah, right, because it's binding minimum. So all of the above. Okay? So answer D. Okay. If deadweight loss is 24,000 under a tax of 4, what is deadweight loss under a tax of 2 per unit? So I know that deadweight loss when tax equals 4 is 24,000. The question is, what is deadweight loss when tax equals 2? Well, what do I know about, what property does deadweight loss have? You know that the deadweight loss of any constant C times the tax, whatever C and tax are, is going to be equal to C squared times deadweight loss at that tax. Right? So from here, I can substitute C with 2 and tax with 2. Right? And what I'm going to get is the deadweight loss at 2.2, 2 times 2, which is 4. So the deadweight loss at 4 equals 2 squared, which is 4, times the deadweight loss at 2. Correct? If C is 2 and tax is 2, right? What I have here is the deadweight loss at a tax of 2 times 2 equals 2 squared times the deadweight loss at a tax of 2. And I know what that is. I know that the deadweight loss at 4 is 24,000.
How do you get C again? I'm sorry.
You don't get it. You just, you notice that 4 is 2 times 2. Right? So there you can apply this formula. If you set C to 2, then this is going to be something that you know. Okay? Right. And this is, so I just substitute now. The deadweight loss, this turns out to be the deadweight loss at 4 equals 4 times the deadweight loss at 2. And this is what I'm after, right? This is what I'm solving for. 24,000 equals 4 times deadweight loss at a tax of 2. So this is 6,000. Right? So deadweight loss when tax is 2 is 24,000 divided by 4, or 6,000. Okay, so here you just need to know the property, this property. Figure it out. Sorry?
Can we just divide 24 by 4?
The question is, can we just divide 24 by 4? But that's what we end up doing effectively, but it's not always going to be the case. What if I give you the tax at 9? Right? What is when the tax is 9? What is dead weight loss? And I'm asking you for when the tax is 3. Then what do you need to do? Well, I'm going to give you this amount, right? So let's say that this amount is 18,000. Let's solve it. All right, new problem. The dead weight loss when the tax is $9 is 18,000. What is the dead weight loss when the tax is 3?
So it'll be 3 times 3 then.
Right, so then the C would be 3. So I'm going to have the dead weight loss at 3 times 3 equals, then this is 3 squared, right, times the dead weight loss at 3. And I need to solve for this, so I'm going to take the 18,000 and divide it by 9. Right? Right, so in our case it was 6,000, which is 8. Another question?
So as long as it's squared, that means that you can divide it by tax and by the amount made. But if it's not like the square root of that number, then you can't do that. Because right now you divided 18,000 by 9, right? Because 3 was squared, which equals 9. And then 2 was squared of 4 is square root of 2, so which is 24,000 divided by 4. If that's the case, you can do it, but other than you can't do it. It's like,
All right, so the question is, do we always divide by the same number squared? And the answer is no. You always follow the formula, right? I can ask you for what is if the tax is uh, 6, right? If I give you the dead weight loss at 6, I can ask you for the dead weight loss at 2, right? But then this would be 3 instead of 2. And then I will divide by 9 again. Right? All right. Okay. Last question. What is the cross price elasticity of demand for complements? All right. So cross price elasticity, what does it tell us?
What is the normal inferior debt?
No, that was...
That's not a complement or something, so.
Right, so the cross price elasticity tells us whether we have complements or substitutes, and what does it depend on? What's the cutoff point for cross price elasticity?
It's negative, it's complement.
Right, so the cutoff point is 0, just like with the income elasticity, right? And it depends on whether it's positive or negative as to whether we have substitutes or complements. So if you don't want to remember it, you can reason like through, just use the formula. So the cross price elasticity is the percentage change in quantity of good Y that is caused by a percentage change in the price of good X, right? So we're going to have 2 goods. Question?
The positive would be complements, and the negatives would be...
We will reason through it. Let's reason through it, all right? So the cross price elasticity is the percentage change in quantity of one good divided by the percentage change in price of another. So let's pick any scenario. The price of good X goes up. Now that immediately means that the quantity of good X is going to go down, right? This is the same good. Now the question is what that is going to do to the quantity of good Y. So imagine we have complements, right? The price of peanut butter and jelly, right? You only buy them together. The price of peanut butter goes up. I'm going to buy less peanut butter, for sure. Am I going to buy more or less jelly? Less, because I only buy them together, all right? So the quantity of jelly is going to go down, and this is when I have complements. So what happened is, well, the cross price elasticity relates this to that. So one went up, the other went down. So the cross price elasticity would be, if this is positive and, negative and this is positive, it will be negative. So when it's negative, we have complements. And the other way around would be when we have, so again, the price goes up, the quantity goes down. But if we have substitutes, Pepsi and Coke, right? So Pepsi is more expensive. I buy less Pepsi, therefore I buy more Coke, all right? So now the quantity is going to go up, and then price goes up, quantity goes up, so both of them are positive. Okay? And then the cross price is positive, and I have substitutes. So when we have substitutes, cross price elasticity is positive. When we have complements, cross price elasticity is negative. So what is it? What is it for complements? Less than 0. All right, guys, that's the end of it. Do you have any questions? Yeah, question?
How similar is this going to be to the test?
Sorry?
How similar is this going to be to the test?
I think pretty similar.
Like, no, I mean, like, the type of questions.
The type of questions on the test should be very similar to those. All right, guys, study hard and good luck.